All right, let's talk about GCP security. I know it's a topic that can feel, well, massive and a little intimidating, but we're going to break it all down today using a really simple idea, building a fortress. So let's get right into it. So I want you to imagine for a second that your cloud environment isn't just a bunch of code and data. Imagine it's a kingdom. Your valuable data, your applications, they're all inside. So the big question is, how do you actually secure a kingdom that's floating up in the cloud? Well, the answer is you don't just throw up one single wall and hope for the best. No way. You build a proper fortress with multiple layers of defense. You've got the main gate, you've got guards on the walls, and you've got a secure vault for the crown jewels. This whole fortress idea, that's exactly how we're going to look at GCP security. Every fortress, and I mean every fortress, starts with controlling who can even get in and out. In the Google Cloud world, that's called Identity and Access Management, or IAM. And honestly, this is probably the most critical layer of them all. It's all about who gets the keys and which doors those keys can open. Now, GCP gives you a few different types of keys. You have your basic roles, like owner or editor. Think of these as the master keys to the entire castle. They're super powerful, but you've got to be really careful with them. The real magic for security is in the predefined roles. These are much more specific, kind of like a key that only opens the door to the kitchen. And if you need something even more specific, you can forge your own custom keys for very, very precise permissions. So this brings us to the golden rule of all security, the principle of least privilege. You just have to follow this. I mean, you wouldn't give the castle chef the key to the royal treasury, would you? Of course not. You give them the key to the kitchen, and that's it. It's the same in the cloud. An app that just needs to read a file shouldn't ever have permission to delete that file. Simple as that. Okay, so what does this look like in the real world? Well, a command like this one is basically you, the architect, giving a direct order. It says, for this project, take this specific service account and give it the storage admin key. It's clear, it's auditable, and it's exactly how you control who gets through which gates. Okay, so we've handled the keys, the gates are under control. Now it's time to build the actual walls and dig the moats. This next layer is all about network security. You know, the big perimeter that protects our entire kingdom from the wild world outside. So your main digital walls in GCP are called VPC firewall rules, and think of them as these huge, thick walls with really heavily guarded gates. Now, here's the best part. By default, every single one of those gates is slammed shut. Nothing, and I mean nothing, gets in unless you specifically create a rule to open a gate and let it in. That default deny approach is an amazing security foundation to start with. Let's quickly break down how you actually build one of these gates. First, you create the rule itself. We'll call this one allow SSH. Then you tell it which wall it belongs to, in this case, the default network. Next, you define exactly what kind of traffic gets through, like SSH traffic. And finally, and this is so important, you say who is allowed to come through by limiting it to a very specific range of IP addresses. Anyone else? Still blocked. But what about the people inside your walls who need to talk to the outside world? This is where it can get a little tricky. Think of it like this. If someone inside your castle needs to talk to, say, the Royal Bank, which is another Google service, they'd use a secure private tunnel. That's private Google access. It keeps all that chatter inside the trusted network. But if they need to get a message out to a village on the public internet, maybe to download a software update, they'd use a special gatekeeper. That's CloudNet. It lets the message out, but it never, ever reveals the private location of who sent it. All right, the gates are controlled, the walls are built, so our focus can now shift inward. We need to protect the most valuable things inside the kingdom, the crown jewels. And this is all about data protection. To protect your jewels, GCP basically gives you a multi-layered vault. Your data gets locked down when it's just sitting there, it's secured while it's being moved around, and you even get the option to bring your own special keys for the locks. But let's look at the most fundamental layer of this whole vault. Yeah, let's just focus on that first layer for a second, because it is so incredibly powerful. By default, without you doing a single thing, any data you store in GCP is automatically encrypted. That is an amazing security baseline. Your data is protected inside the vault from the very second it gets there. But what happens if one of your own people accidentally tries to walk out of the vault with a crown jewel? Well, that's where data loss prevention, or DLP, comes into play. You can think of it like a super smart guard who can actually recognize sensitive stuff, like a credit card number, and automatically block it out before it ever gets exposed. You know, a really secure fortress isn't just about static defenses. It's got to be alive. It needs guards patrolling the walls, it needs alarms, and it needs watchtowers to spot trouble before it even gets close, and to deal with threats that might already be inside. And the really good news is that for pretty much any threat you can think of, GCP has a specialized guard for the job. Worried about your virtual machines being tampered with when they start up? Shielded VMs have your back. Worried that someone left a gate open by accident? Security Command Center will find that misconfiguration for you. It's like having a dedicated security patrol for every single part of your kingdom. So the Security Command Center, or SCC, is basically the central watchtower for your entire kingdom. It's that single pane of glass where you can see everything that's going on, an inventory of all your stuff, alerts for any weaknesses, and active threat detection. It's the place where the Chief of Security would stand to oversee the entire operation. And if something does happen, well, that's where cloud audit logs come in. They are your official, indisputable record. Think of them as scribes who are meticulously writing down every single important thing that happens. Who opened a gate? Who went into the treasury? And when did they do it? For figuring things out after the fact, these logs are absolutely essential. So let's just step back for a minute and take a look at what we've actually built here. We've gone layer by layer and we've constructed a really robust, really defensible kingdom right here in the cloud. So here it is, the blueprint for your fortress. You start with identity, controlling the gates with IAM. Then you build out your perimeter walls with firewalls. Inside those walls, you encrypt your crown jewels, your data. And finally, you post guards and you set up watchtowers with SCC and audit logs to keep an eye on everything all the time. Each layer just works together to make the whole thing stronger. The tools are powerful, the defaults are incredibly strong, and the blueprint is clear. Your fortress is built, the guards are on watch, but that leaves us with one final and really crucial question to think about. At the end of the day, who is ultimately responsible for making sure the gate is locked at night?